Good morning, students. So, in this class, we are going to discuss about plumes in meteorology. So, what is plume? So, plume is defined as the path and its extension in the atmosphere of the emitted gas from the source. This source is generally referred as a stack. In general, plume is an air column in which one air is moving through the another. That is called as plume. Here, what is plume rise? So, plume rise is defined as distance of the hot plume from the stack into the atmosphere due to the buoyancy and the momentum effect. So, this is called as plume rise. Next, coming to the general characteristics of stack plumes, the first one is dispersion of pollutants. Second one is the wind carries pollution downstream from the source. Third point is the atmospheric turbulence causes pollutants to fluctuate from mainstream in vertical and crosswind directions. Fourth point, mechanical and atmospheric heating both present at same time but in varying ratios. Fifth point, it affects the plume dispersion differently. Okay, so the next one is dispersion characteristics of stack plume. Okay, so what is the dispersion characteristics of stack plume? The plume types are important because they help us understand under what conditions there will be higher concentration of contaminants at a ground level. So third, so coming to looping effect. So what is looping effect? That is the high degree of uh, convective turbulence effect. So here the disturbance and turbulence effect is very high. So from the picture itself we can say that this kind of effect is called as looping effect. And here super adiabatic collapse rate, that is the strong instabilities occurs. Okay, so adiabatic means the process takes place without any exchange of heat transfer between two effect, that is called as adiabatic. So super adiabatic collapse rate means a strong instabilities will be happening. So next one is associated with clear daytime conditions and accompanied by strong solar heating and light winds. Okay, so third point is high probability of high concentrations at ground level close to stack. So here the concentration will be high at the ground level. So next one is last one is it occurs in unstable atmospheric conditions. Next one is coning effect. So what is coning effect? Thus it is stable with small scale disturbance. The disturbance is at a very small scale. So associated with the overcast moderate to strong winds. So roughly it is about 10 percentage. Okay, so the fourth point is pollutants travel fairly long distance before reaching ground. It must be traveling a long distance because the here in this picture it represents the uh, that is uh, the distance from the ground level is somewhat high, so it takes some few more long distance before reaching ground level in significant amounts. So last point is it occurs in neutral atmospheric condition, that is called as coning effect. Okay, so the next one is fanning effects. Fanning effect means it occurs under large negative lapse rate. Okay, the strong inversion at the considerable distance above the stack. Okay, so in this the fanning effect itself, you can say the disturbance will be less, and it is extremely stable atmosphere. And here the disturbance is little. So if plume density is similar to air travels towards downward at approximately same elevation, so the height is at same stage. So next effect is lofting effect. So lofting effect means it is favorable in the sense that fewer impacts at ground level. Pollutants go up into the environment and they are created when atmospheric conditions are unstable above the plume and stable below. Next one is fumigation effect. So what is fumigation means? That is most dangerous case. Here the disturbance are so high. Okay, so they are created when atmospheric conditions are stable above the plume and stable above the plume and unstable below. Okay, so here this happens most often after the daylight sun has warmed the atmosphere, which turns a nighttime fanning plume into fumigation for about half an hour. Okay, so the next one is that's